Hi everyone, my name is Noah and I work for Intuit, and I'm here to tell you about how we are surfacing hidden user data, as it says. I should start by telling you a little bit about Mint, which is our product that we developed this project for. And in a sentence, it's Intuit's personal financial advisor. And there's a lot of things you can do in Mint, and basically it keeps track of all of your finance. All of your accounts should be aggregated there. You can manage budgets, you can pay your bills, and you also are getting tailor-made, custom-made financial, sorry, I'm sick, advisement and insights. And the nice thing about that is that the way we're able to produce those custom-made advisement, prescription, and predictions is by the user, it's by the data the user provides us. The user tells us which accounts he or she has, which financial accounts, and by that we're able to produce those prescriptions. However, the problem is that sometimes, the user not providing us with all of their accounts. Sometimes, and it can happen mostly because they're just forgetting to let us know that they have some other financial accounts, like in this illustration here about the Citibank. So, as we can guess, without having complete data, all of the prediction and analysis can be inaccurate, and therefore all this custom-made advisement is not so relevant. So the goal we set to ourselves was to complete the Mint user data. And this is an unsupervised problem, obviously, because no user is signaling us that they are having another account that they're not telling us about. So what we have to work with was just the existing Mint data, which looks sort of like that. This is fictional data, obviously, but we have transactional data from all of the users' different accounts that we know of. What we understood, the key observation we made was that if a user have multiple accounts, then they will move money between those accounts. And if those two accounts, for example, are listed in Mint, then we should be able to see such transfers from both ends. As you can see here, dates are adjacent and the amounts are the same. The description shouldn't be the same. There's no forcing on that one, and we will get back to that one. But what we figured out was that if a user didn't list an account, then we should see kind of transfers, but we will see only one end of them in Mint data. So what our model did was basically learn how personal transfers look like, and we did that based on mostly the textual features of the description of such personal transfers, and also with other characteristics like the amounts and the time of day and so forth. And so we said, if we find something that fits, that our model said it's a personal transfer, but we don't see a pair to it, then this means there's another account that we don't know of. So, all right, we have those unlisted accounts, but what can we do to make the user add those accounts? How can we do that? So we had some wishful thinking here, and we said, let's say what if we not only knew there's a missing account, but we also knew which bank this account is hosting? Like, for example, here, this is in Bank of America. Then we would be able to say to our user something like, would you like to add your Bank of America account? Click here. The path would be short to add the account, and the trust between the user and the app would be increased, because the app should be a smart app. So how can we do that? How can we figure out which bank hosts those missing accounts? What we understood was the pairs from before that I've mentioned that we detected within the Mint data were actually a good base for constructing a supervised framework for solving this problem. Because for those pairs, we actually have that other field that we want to guess, we want to find out, the other account host, other account hosting bank. So we have now data points that have everything we need to learn how bank describes transfers, which bank is on the other side of a transfer that looks like, I don't know, this or this. So if we take a step back and look at the problem that we're trying to solve, let's say there's a transfer being generated and documented in Chase Bank. So this is the way Chase Bank described it, but Chase Bank has like all those logics and rule-based mechanism that says how they describe a transfer to Bank of America. And theoretically, the question of which bank is on the other side is one with a deterministic answer to. But learning all of those rules is not feasible because there's so much banks, and each bank has this ramified rule-based system. So we decided to take a statistical approach to learn those. And then now we're handling with this asymmetric classification problem with multi-class, multi-labels classes to predict. So what we did was taking those transfers from the data that we constructed, feeding them to either a text embedding layer or maybe engineering from them textual, like linguistic features for a machine learning model, then using that in either a logistic regression worked best for the machine learning or either LSTM model, and then just produce the prediction. The fact is that the results were very nice with 2 million observation, and I'm reminding you there's like hundreds of banks, so this is hundreds of classes. We were able to do like estimate the accuracy 0.88, the LSTM did that, and that's true for both debit and credit type transactions. That's the asymmetric, I'm sorry I didn't mention, it's because banks do this differently when the transfer is outgoing or either it's ingoing. So it's like hundreds of banks twice, the labels. This is it, those are the results. Just to conclude, I have time to show you. This is a visualization of what the models are basically doing. They're like, we can see within the transfer description, the text, how all of America's financial system is being clustered. For example, you can see this very bright cluster in the middle of the 3 branches of BB&T Bank. They're describing money transfers to different banks the same way within themselves. They have the same system to do that. And also you can see in the bottom there's another cluster of PNC Bank, and it's interesting because one of those banks are actually a bank was acquired recently by PNC. So we can map that way all of the financial institutes in America. So that's cool. And that is it. If you have any questions.